Projective Geometry, Volume 1, by Oswald Veblen and John Wesley Young. Chapter 4, Harmonic Constructions and the Fundamental Theorem of Projective Geometry. Section 32, Nets of Rationality on a Line. Definition: a point P of a line is said to be harmonically related to three given distinct points, A, B, C, of the line, provided P is one of a sequence of points, A, B, C, H1, H2, H3, of the line, finite in number, such that H sub 1 is the harmonic conjugate of one of the points A, B, C with respect to the other two, and such that every other point H sub I is harmonic with three of the set A, B, C, H1, H2, H sub I minus 1. The class of all points harmonically related to three distinct points A, B, C on a line is called the one-dimensional net of rationality defined by ABC. It is denoted by R of ABC. A net of rationality on a line is also called a linear net. Theorem 7. If A, B, C, D, and A', B', C', D' are respectively points of two lines such that A, B, C, D is projective with A', B', C', D', and if D is harmonically related to A, B, C, then D' is harmonically related to A', B', C'. Assumptions A and E. This follows directly from the fact that the projectivity of the theorem makes the set of points H sub j, which defines D as harmonically related to ABC, projective with a set of points H sub j prime, such that every harmonic set of points of the sequence A, B, C, H1, H2, D is homologous with a harmonic set of the sequence A', B', C', H1', H2', D'. Theorem 3, Corollary. Corollary: if a class of points on a line is projective with a net of rationality on a line, it is itself a net of rationality. Theorem 8. If K, L, M are three distinct points of the net of rationality of ABC, ABC are points of the net of rationality of KLM. Assumptions A and E. Proof: from the projectivity ABCK projective with BAKC follows by Theorem 7 that C is a point of the net of rationality of ABK. Hence, all points harmonically related to ABC are, by definition, harmonically related to ABK. Since K is, by hypothesis, in the net R of ABC, the definition also requires that all points of R of ABK shall be points of R of ABC. Since the nets R of ABC and R of ABK are identical, and so R of ABC is equal to R of ABK is equal to R of AMK is equal to R of KLM. Corollary: a net of rationality on a line is determined by any distinct three of its points. Theorem 9. If all but one of 6 or 5 or 4 points of a quadrangular set are points of the same net of rationality R, this one point is also a point of R. Assumptions A and E. Proof: let the sides of the quadrangle PQRS, figure 37, meet the line L as indicated in the points A1, B1, C1, so that B is not equal to B1. And suppose that the first 5 of these points of a net of rationality, R equal R of A1, B1, is equal to R of BC, B1, is equal to ... We must prove that C1 is a point of R. Let the pair of lines RS and PQ meet in B'. We then have BC, B1A is perspective with center S to BQ, B'P is perspective with center R to BA1, B1, C1. Since A is in R of BC, B1, it follows from this projectivity in view of Theorem 7, that C1 is in R of B A1 B1 is equal to R. Definition: a point P of a line is said to be quadrangularly related to three given distinct points A, B, C of the line, provided P is one of a sequence of points A, B, C, H1, H2, H3, ... of the line, finite in number, such that H1 is the harmonic conjugate of one of the points A, B, C with respect to the other two, and such that every other point H sub I is one of a quadrangular set of which the other five belong to the set A, B, C, H1, H2, ... H sub I minus 1. Corollary: the class of all points quadrangularly related to three distinct collinear points A, B, C is R of A, B, C. Assumptions A and E. From the last corollary, it is plain that R of A, B, C consists of all points that can be constructed from A, B, C by means of points and lines alone. That is to say, all points whose existence can be inferred from assumptions A, E, and H0. The existence or non-existence of further points on the line A, B, C is undetermined as yet. The analogous class of points in a plane is the system of all points constructible by means of points and lines out of 4 points A, B, C, D, no 3 of which are collinear. This class of points is studied by an indirect method in the next section. Projective Geometry, Volume 1. This book was written by Oswald Veblen and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renhold, with programming and illustration by Jim Renhold, 2019. Thank you for listening.